back to Build Propulsion Lab at DevOps Belgium 2024, day 2, and my first guest of the second day is Roni. Welcome, Roni.
Hey, great to be here.
Thank you very much for joining. And Roni, you mentioned a topic that is very dear to our heart here in the Build Propulsion Lab, and that's feedback. It's obviously dear for our Build Propulsion Lab because Build Propulsion Lab is about developer productivity, and short, consistent, continuous feedback is one of the most important factors of developer productivity.
For sure, for sure.
So tell me, why did you want to talk about it? What is it about? Why it is important? Tell us everything about continuous feedback.
So first of all, I'm a developer in my background, and like many other things, I became very passionate about continuous feedback because I was very frustrated with the lack of it. And I think for me, my epiphany moment, and maybe this will explain what we're trying to do or what I'm trying to convey here, was something that happened to me working with my dev team, where one of the developers was actually refactoring the data access layer, and he was doing this amazing, huge change, supposed to bring about a great kind of performance improvement. And he worked on it for weeks, and then he checked in his code, and everybody was happy, and we just moved on to the next item. And it took us about maybe 2 months to discover that his code never ran in actuality in production, because it was just one if statement away from being called. It was feature flagged away. Now, like, jokes aside, I went to the developer and I asked, oh, what's up? Like, why didn't you check that your code was actually running? And he just looked at me and he asked me, well, how? And the fact that I didn't have a very good answer for him, and the fact that he would actually need to manually go and check, both of these facts didn't align quite in my head, and I had to think about what's going on here. What are we missing? Because there's obviously a missing piece.
So I think one of the reasons that happen, and generally happens, things like that, is that when we talk about observability, it's in our brain, it's very production area term, right? So when we talk about, hey, do we have observability? Everybody, sure, yeah, of course, we know exactly when our product, when our service is down. But when we look at our development environment and the pipelines and the build and the CI and all this kind of stuff, we have zero observability, right? So we can see what's going on in our code, we can run our tests, we can assume that parts of our code are working maybe correctly, or at least the test passed. It doesn't mean that it works correctly, but at least the test passed. But this is all observability we have. And the questions like, hey, do my code actually run in production, have absolutely no answers.
Definitely, and I think it goes beyond that. I think the tragedy might be related to the fact that observability indeed evolved from monitoring. So it was mainly just, do I have an issue in production or do I not have an issue in production?
Yeah, the side-down detector. That's the origin of all observability.
I've been talking to so many developers here, and I can confirm that 100% of the time, the very narrow scope in which the amazing data that observability holds today is being used is actually this one scenario, which is there is a problem in production, I go check the logs, I find a responsible log or trace or metric, I root cause analysis, and I solve the problem. But I would have to ask you this. The log or trace or metric, they were there all along. Why did we have to wait for the production bug? Why did we need to wait for an issue to come up in the monitoring system and so on, where the information was there?
Yep.
And one of the things that I also shared in my talk is that I felt kind of like an archaeologist, where I was digging around, trying to excavate evidence of what happened, whereas the evidence was there all along. There was no need to have this reactive process. We could have something much more proactive, and the key is information. So then we have to ask ourselves, why is it not happening? Why are we reduced to this very limited use case? Why is information flow not happening?
So for me, one of the reasons is, and I think it's a valid reason, is that in the end of the day, what really matters to the business is what the customers see, right? And this is why kind of production rates. This is the most important part of every business. Is our product actually working? Can we charge for it in the end of the day? That's the question, right? Can we ask for money for something that is working reliably and so forth? And this is why we were obsessed, and we still are, for a very good reason, about production, about how does it feel? Is it up? Is everything okay? But I think it's a solved problem, right? I mean, we figured this shit out. We know exactly how to do it. And at the end of the day, you don't need to rely on customers complaining on Twitter or X that our production is down, right? So this is solved. The question is, okay, now we have all this data that we gathered for this glorious purpose of having the production up and running. Can we do more with that? Can we improve developer productivity, for example?
Exactly, and I hear so many people talking about developer velocity, talking about even the cost of an issue in production and then remediating it is 100 times more than preventing it in the first place. But there are reasons it's not happening, and a part of them are an information problem. And this is where I'm really happy. Why? Because information problems we know how to solve.
We can solve.
If it's a product problem, maybe we need to think about it. Information is, we have the technology, as we say.
Okay, so what do we do? What is the missing piece that is easily solvable to make our life as developers and engineers, our productivity better, our lives better?
So why are we not doing it? For several reasons. First of all, it requires effort and it requires expertise. And it's not continuous. So just like testing, they never worked until they were continuous. When we were doing testing, and I'm kind of old enough of a geezer and a programmer to remember the days where we were running test builds manually. Nobody wanted to be stuck with the task of running the test build. They were always red. You always had to fix them. And the same goes for observability. Nobody wants to be tasked with the task of kind of looking at different logs and traces and looking for trouble, right? However, if the process is continuous, if it is a part of the process of development, then that's a necessary component. I kind of take this analogy. If you were able to take a developer and tell him, train him in data models and in machine learning and in statistics, give him one job, 24 hours, to look over traces, metrics, and logs and find emerging problems and give feedback to the developers as they code. That would be amazing, except that nobody has the resources for something like that. So this is where a tool can come in.
And also, frankly, if you do that, this developer will automate the shit out of it the second week they're on the job. No one wants to do it manually. They would train the model to detect those anomalies and just leave it to it.
Definitely.
Okay, so
this is what we found ourselves doing at Digma.
Right. So how do we do it? What do we do?
And this is the necessary component. How do we actually automate the data analysis? And one of the things that I'm here kind of talking about and also presenting in my booth is the tool that we created, which is completely free for developers. It's not a selling pitch. It is get and give me your feedback on what you're saying pitch, which is we're running on the pre-production environments as well as production, but with an emphasis on the pre-production environments. We have baked into this tool all of the know-how and knowledge about what issues to detect, how to detect them, and how to provide feedback to the developers in your CI, in your IDE. And using that, we can actually take a lot of information that right now is being largely ignored.
So what kind of information can be detected using this tool? What are we talking about?
So different types of issues that are, I went through this conference lately and I showed everybody a trace of an example app I was running with like a pet clinic or something. And we could all look at the trace and I asked the audience, what do you see here? And everybody raised their hand and say, okay, that's an N+1. Why? Because we're an expert developers and we know to detect these issues. So if it is a bad query, if it is a missing index, if it is something that has to do with scalability or performance, if you've created a bottleneck, if you had added different types of added patterns that can be detected in the runtime, this is the information we need to get back. When? As we're still working on the code. It can become a bug and we'll fix it 3 months from now, and it might not have kind of the same, it will take us twice the time to fix it, and it will context switch us away from our work, which is even more expensive.
So this is the continuous feedback we were talking about, right? So as you write code, the tool will alert you that you're doing something wrong, will show you the bug immediately, and you will be able to course correct before it gets...
This is kind of the tip of the iceberg, but if you kind of start digging deeper, you'll see that information is actually very useful. For example, in your pull request, you want to see what you impacted, which flows in the system are impacted. Where is that information in the observability? How easy is it to access? Not very easy. The same way you can think about usage in general. We were talking before about the developer that didn't know whether his code was being used at all. Dead code is something you can find in observability. How easy it is to find? Not very. And this is kind of where we can start closing the distance between a lot of useful information, treasure troves of information that are captured right now. We're paying a fortune to store all of these spans, all of these traces, metrics. We're paying, the APMs of the world a lot of money for that, but we're not using them as much, except in that one scenario we discussed at the beginning, which is production troubleshooting.
All right. So where people go, how they can learn more, what they should do.
Perfect. So we are just an IntelliJ plugin. All of our data is local, so we don't send any data to the cloud, and it doesn't cost any money to install. If you go to our booth, there is also a QR code there with a competition, and I want to challenge everybody to join the competition. The competition is very simple. You install the plugin, you enter the competition code, and you run your code. Digma, there is no code changes necessary, and Digma will already collect data about it. If your code is perfect, you will win nothing because you don't deserve it. You already have perfect code, you don't need our prizes. However, the more issues you have that Digma will find, the more your chances are to win the grand prize. And we have gift cards, we have a really amazing spyglass, and we have some other really great prizes.
I really need to participate. I think I have a very, very good chance.
Just one thing, it is anonymous, so you will not be wearing a badge of shame for showing up with a laptop full of critical issues. But it's definitely worthwhile, even if you just are curious and you want to see what type of issues you can come up with.
I love it. I love it. This is great. Roni, thank you very much.
My pleasure.
It was very, very insightful. And you folks, if you want to learn more about developer productivity in general and a bunch of topics that our speakers are going to talk about with us in particular, we have full days of interviews ahead of us. So stay tuned for more episodes from the Ball Propulsion Lab here at DevOps Belgium 2024. Thank you and stay tuned.
Bye, guys.